Welcome to the 72nd video in our series about Unix tools. In this video, I'll show you the same project from videos 70 and 71, and I'll show you how to create a shared library instead of a static library. As you see on the screen, I've shown the subgraph for the static library we created last time, with the static library name at the top and all the dependencies. For a shared library, the dependencies are the same, but the name of the library is different. A static library has the form lib_whatever.a, and a shared library has the form lib_whatever.so, and usually .some number. So, how do we do it? You can see the commands in the window. The first two commands are exactly the same as last time, except that we have to have fPIC for position independent code. Shared libraries are required to use position independent code. But otherwise it's the same. You compile the C code into an object file. And then here is the difference. Okay, when we compare with last time, you can see, wow, we've got a lot more options. We say GCC, and then we say shared, which says I want a shared library, and then we have to give the SO name, the shared object name, and this is a special name. It should be lib, and then whatever you want your library to be, .so, and then some number that represents the version. If it's a new library, use .1. And then we use a -o, like we did before, to specify the output file, and you give that same name you had here, but you can add a trailing digit for the subversion. And subversions have to use the same API. Okay, they have to have the same functions with the same signatures. But each version of that, you can change this final digit 0, 1, 2, 3, 4 as you release new versions of the library. But all of those libraries that have the same SO name, and of course that has to be this part, they all have to have exactly the same function prototypes, and if you have any variables, the types and names must match exactly 100%. If they don't, you've got to change this to a 2, and you start over here with 2.0 again. Okay, after you've listed the output name, you list the object files that you want to be included in that shared library. After you do that, you need two symbolic links. The first one uses the full output name and links that to the shared object name. The second one links the shared object name to the .so with no numbers at all. After you've done that, your shared library is ready to use. The next thing you need to do is compile your C code that has the calls to the shared library and has some main in it. In our case, it's all in one file, testit.c. Although Factorial and Taylor sign, they can call each other because they're both inside the shared object. For our design, if you remember, Taylor sign calls a factorial function. The final link that's going to connect up this shared library and this object code is shown here, and you need to repeat that fPIC again just to be safe, and you give the object file that you created, that's the one that has main in it, and then you specify -o and the name of the executable that your executable program we're creating, and then you have to give some options. We have to say where to look, and we want to look in the current directory, so we say -l dot. And finally, we do a -l mylib. So this part looks the same as we did for static libraries. But the rule is if there's a static library and there's a shared library and this line doesn't say static anywhere on it, it's going to use the shared library. And -lm, I hope you remember, that's used by testit because testit uses the system sign function, which is in this libmath library. Okay, that's what we need to do. Let's do it. And you can see we're ready to go. So let's compile with position independent code the factorial.c into the factorial.o object file. Let's do the same thing for Taylor sign. So compile the C file into an object file. But remember, these are position object, position independent code now. The next step is to create that shared library. And you have to think back. How did we do it? We can do a quick grep for when you want to grep and something starts with a minus, you need to put a double minus here to tell grep I'm done with any options. If you see a minus as part of my pattern, and you give the pattern and the file, and that'll tell you exactly what we need to type. And it worked. Now we need to set two symbolic links. If you remember, ln-s makes it symbolic. I haven't had a video about links yet because they're a little confusing. Right now you need to treat this as magic and use a cargo cult attitude where you just, you copy it and you believe it. You don't know why. You just know you have to do it. In a later video, I'll explain symbolic links for you. That's the first one. That links the actual output, which we specified here, with the SO name, which we specified here. The second symbolic link looks very similar, and you link this one, which was the SO name, with the same thing with no numbers. Okay, we've done the shared library stuff. The last thing to do is to compile testit and I forgot the -c. I am a bad man. Sorry about that. There we go. And now let's do the link. And the link, this time, this was a first link to create the shared library. The second link is to use it. So we say GCC, and we should really specify fPIC again just to be super safe. And then we're going to say, I want testit.o, and I want to output that into testit. For the libraries, look in this directory, and I want mylib. And just like we didn't put the .a, you don't put the .so, and just like we didn't include the lib, but it has to be there, you don't include the lib down here in your line, but it has to be there in the file. Okay, and then the last step was I told you we have to do an lm to link the system math library so we can use the sign function in here. Okay, it looks good, and you're ready to run it, but watch what happens if we aren't careful and we just try to run it. It says I can't do it. Now we told it where to look, but that was at link time. At runtime, we're going to have to do a little more work because the current path home John Yo is not a system path. We have to set up an environment variable. So we have to do LD library path equals this directory. Right? You can do that, or you could spell it out. Home John Yo. And then if we run test it, we get the output we expect. But then it's not going to remember that. If you wanted it to remember it for the whole session, you can do an export. And now if we do test it, it remembers. This is a special environment variable used to tell the system program loader that it should look here if it can't find the library you want, which we requested, anywhere else. And how would we know what libraries test it's using? You can use that command, LDD tree, and this tells you, it needs this, I'm getting it here. And it needs this libm and this libc. Libm is the one that has sign in it. Libc has our printf, and it also had our exit success and our exit failure that we used. And we've run out of time in this video. So I hope you come back for the next video when I show you how to do a makefile for the shared library, because we have to make some changes. But until then, thank you for listening.